Lesson 8-3 is about proving whether triangles are similar. Don't let the word prove freak you out or make you think it's hard. It's not. In Lesson 8-2, we talked about lots of shapes and what similarity was, and you can set up a proportion and find the extremes to find missing things once you have similar objects. You can write similarity statements. Lesson 3 is just focusing just on triangles to make it a little bit easier. With triangles, you actually don't need to know as much information as you would with other shapes to show that they're similar. In fact, there's three main ways to show it's similar: AA, SAS, or SSS. We're supposed to illustrate what they mean. I'm going to go through them. So the first one, SSS. With an SSS, sorry, my computer's freaking out here. With SSS, it stands for side, side, side. You can use it when you know all three sides of both triangles. So if I have two triangles, in order to use it, I have to have numbers, specifically numbers, on all three sides. Obviously, my drawings are not to scale, but you have to show all three sides. You must show that all three ratios are equivalent. So in mine, the yellow goes with the yellow side, so my ratio is 2/4, which is 1/2. Then on the blue side, those are the ones that go together. So 4/8 is 1/2. And I'll call the pink side, that'd be 3/6 is 1/2. If I have all three sides and I show that all three fractions are the same, that is SSS. Writing a similarity statement is just like before. I'd have to label my corners, my vertices, in order to do that. The second one you could use is SAS. In order to do this, you need to know two sides on both triangles, and you also have to know that the angle in between the two sides, which is called the included angle, and I really should say angles because there's one for each triangle, so the angles between the given sides are congruent. It can also often be done with an angle marking. So draw my little triangles. So I know two sides, so I'll say this one's 3 and this one's 5. Oh, let's make that way easier. Let's make that 6. And that this one is 4 and this one is 8. I have two sides, and the angle that's in between those two sides is the same on both. That's enough information. So to use it, the angles have to match, and the two ratios have to be equivalent. So I only have two of those to set up. So my yellow side is 3/6. I made it easy, 1/2. My blue side, 4/8, which equals 1/2. and the angle was marked the same. So that's how you would use SSS. The final one is AA. To use this one, you need to know that two of the angles match two of the angles in the other figure. In this case, there's no fractions to do. You just have to show the two angles. So if I have, right, maybe I don't know their sides at all, but I know maybe this one they mark as 90 and this one they mark as the same. That's all I need to know. Two angles match. That's enough for AA. Now that I've made this look really easy, what are the tricks they're going to do to remind you of things? So, angle tricks. You must remember that vertical angles are congruent even if they're not marked. So if I have two lines that are crossing and I have two triangles, even if it's not marked, this angle has to match this angle. The next thing you have to remember is shared angles. Whenever they give you a triangle in a triangle, you should draw it as two separate triangles and mark, remember that this angle is the same in both of the triangles. So just know that shared angles are always the same. And the third one that you're going to have to remember are alternate interior angles. Interior angles. And those happen only when you have parallel lines. So it could happen in two ways. So you could have parallel lines here. If those lines are parallel, this angle automatically matches this angle, even if it's not marked. You can add that marking. This angle matches this angle. So if those are parallel inside, they're automatically similar triangles because those angles line up. The other way that the parallel lines happen is when you have something like this, and maybe they have parallel lines along the outside edge. When the parallel lines are on the outside edge, this angle would line up with this angle automatically. Doesn't have to be marked. It's just true. And let's see, let's get another color here. This angle lines up with this angle. So do beware of this. Where people end up getting confused is that means this side corresponds to this side and this side corresponds to this side. So don't screw up your similarity statement or your proportions with that. That one's just a little bit tricky. So let me just do a couple of the harder examples. Let's say they tell you that the triangles are similar and they ask you to find the missing parts. So first one, they are similar. I'm just going to tell you that they are. I'll just put the little parallel markings. They're automatically similar if those lines are parallel. And maybe they tell you that this is 5. I want to know what x is. And let's see if that's 5. This is 4. And this is 6. Whenever you have a triangle in a triangle, redraw them. So I have a small triangle and a big triangle. I know this is 6 and this is 4. This is 5. This is where people get confused. The big side here would be 5 plus x, because I have both of those things added together. So that means 5 became 5 plus x, and 4 became 6. I cross multiply. 5 times 6 is 30. Sorry, extremes is what I mean by cross multiplying. When I multiply by 4, going the extreme this direction, do make sure you distribute that 4 to both items. So that'll be 20 plus 4x. Solve that out. Subtract 20. 10 equals 4x. That gives me x equal to 2.5 after I divide by 4. So there's one problem they give you that's a little bit on the tricky side. The other ones that they might give you, also parallel ones, and I talked about this a little bit. So let's say these are parallel. When those are parallel, and only when those are parallel, be careful because this side lines up with this side, and this side lines up with this side. So as example, let's say I had, that's going to be 4 and 5 and 3 and x. And I'm going to go left to right. That means the 4 is becoming the x and the 3 is becoming the 5. So my extremes, 4 times 5 is 20, 3 times x is 3x. I divide by 3. 20 divided by 3 is, well, I'm going to call it 20/3. Okay, fine. 6 2/3 if you prefer. I'm okay with 20/3. So just be careful. Sometimes you have to know what becomes what, I guess. And if those are parallel lines, this angle right here corresponds with this angle because those are the alternate interior angles. In other cases, let me go ahead and do one more example. Example that doesn't always have to be the case. You could have an example where they're not parallel lines, and sometimes it's hard from the drawing to know whether they're parallel lines, but maybe they tell you that this lines up with this. I'm going to do the same problem. 4, 5, 3, x. In this case, the 4 and the 5 are the ones that go together, and the 3 and the x are the ones that go together. So 4 became 5 and 3 became x, which means 15 equals 4x. Divide by 4. So 3.75 equals x. So it's very different. You have to be very careful, as if that's a word, careful about which sides line up. But the big tricks is make sure you understand what parallel lines are telling you about angles. And if you have a triangle within a triangle, write them as 2 separate triangles and fill in everything that you know. That's just going to help you a lot on those problems.